Imagine you are standing on a vast, endless beach. The grains of sand stretch out in every direction, more than you could ever hope to count. Now, reach down and pick up just one single grain. Hold it in the palm of your hand. Feel its tiny weight. See its simple shape. That one grain of sand is our sun. It is the star that gives us warmth and light. The star that our world, the Earth, orbits every year. It feels so important, so central to our existence. But when you look at the beach around you, you begin to understand something profound. Every single one of those countless other grains of sand is also a sun. Each one is a star, perhaps with its own planets, its own worlds, circling in the distance. Our sun is just one star among billions. All the stars you can see in the night sky, and all the ones you can't, belong to a gigantic city of stars we call the Milky Way galaxy. This galaxy is our home, a swirling, beautiful spiral of gas, dust, and at least 100 billion stars. It is so large that a beam of light, the fastest thing in the universe, would take 100,000 years to travel from one side to the other. And our sun, our tiny grain of sand, is located far from the center, in one of its quiet, spiraling arms. This is our neighborhood, our place in the cosmos. It is a place of staggering scale and breathtaking beauty, far bigger than we can truly imagine. But the story does not end there. If our sun is a grain of sand and the Milky Way is a beach, then what lies beyond that beach? The answer is almost too much to comprehend. There are more beaches. As far as our most powerful telescopes can see, there are other galaxies, other great islands of stars, scattered through the darkness of space. There are hundreds of billions of them, perhaps even trillions. Each one is a collection of billions of suns. The total number of stars in the universe is greater than all the grains of sand on all the beaches on Earth. Our place in this cosmic ocean is infinitesimally small. Yet from this tiny vantage point, we've begun to piece together its story. This understanding of our place in the universe is a very new idea. For most of human history, we believed something very different. We thought we were the center of everything. The Earth was the most important place in creation, and the heavens were made for us. The journey from that comforting, simple picture to the vast, complex, and far more wonderful reality we now know is one of the greatest adventures in human history. It is a story of curiosity, of courage, and of looking up at the night sky and daring to ask simple, powerful questions. It is the story of how we discovered the true scale of everything. For thousands of years, people all over the world looked up at the same night sky. They saw the moon change its shape, and they saw a few bright points of light. The planets wander slowly against the background of stars. But the stars themselves seemed different. They appeared to be fixed in their positions, like tiny, glittering diamonds sewn onto a great, dark curtain. Every night, this celestial curtain would turn above the Earth, but the patterns of the stars, the constellations, never changed. They were constant, perfect, and eternal. This unchanging nature of the heavens was a deep and powerful idea for our ancestors. It was a source of comfort and predictability in a world that was often chaotic and uncertain. This idea was formalized into a model of the universe that placed the Earth at the very center of everything. Around our world, it was believed, were a series of invisible, nested crystal spheres. The moon was attached to the first sphere, the sun to another, and each of the wandering planets had a sphere of its own. The final, outermost sphere was the one that held all the stars. This was the edge of the universe. The stars were thought to be perfect, unchanging lights, fixed forever to this celestial shell. Beyond it, there was nothing but the realm of heaven, the abode of the gods. This picture made perfect sense. It explained what people saw every night and placed humanity at the heart of creation. Everything within this model had its place. The Earth, where we lived, was a realm of change, decay, and imperfection. Things were born, they grew old, and they died. But the heavens were different. They were thought to be made of a fifth element, a perfect substance called ether. This celestial realm was eternal and unchanging. A star could not be born, and a star could not die. The idea was so powerful that it became the foundation of science, philosophy, and religion for nearly 2,000 years. It was a beautiful, ordered, and deeply human-centered vision of the cosmos. It was also, as we would come to discover, completely wrong. The universe is not static or perfect. It is a dynamic, evolving, and often violent place. Stars are not eternal lights fixed to a distant shell. They are born from colossal clouds of gas and dust. They live for millions or billions of years by fusing elements in their cores, and then they die. Sometimes they die in the most spectacular way imaginable, in an explosion so bright it can outshine an entire galaxy. An event like that is impossible in a universe of perfect, unchanging spheres. And in the late 16th century, just such an impossible event appeared in the sky, forcing everyone to question everything they thought they knew. The year was 1572. On a cold November evening, the great Danish astronomer Tycho Brahe was walking home when he noticed something strange in the sky. There, in the familiar constellation of Cassiopeia, was a new star. It was not just any star, it was astonishingly bright, shining more brilliantly than the planet Venus. It was brighter than any other star in the heavens. This was a profound shock. According to the ancient wisdom, the heavens were perfect and unchanging. A new star simply could not appear where there was none before. Yet there it was, a brilliant, silent visitor, challenging 2,000 years of certainty. The impossible had happened. Tycho and other astronomers across Europe watched the new star with fascination and confusion. They carefully measured its position night after night. They wanted to see if it moved. If it was close to Earth, like the Moon or a comet, its position against the distant background stars should shift as the Earth turned. This effect is called parallax. But the new star showed no parallax at all. It remained perfectly fixed among the other stars of Cassiopeia. This could only mean one thing. The new star was not something in our atmosphere or even nearby in the solar system. It was located far away in the realm of the fixed stars, on that supposedly perfect and eternal crystal sphere. This discovery, which we now know was a supernova, the cataclysmic explosion of a dying star, sent a shockwave through the intellectual world. It was a direct, visible contradiction of the ancient model of the universe. The heavens were not unchanging after all. A new light could appear in the realm of the stars, shining with incredible brilliance for months before slowly fading away. This single event was a crack in the crystal sphere, a deep fracture in the old way of thinking. It proved that the cosmos was a place of change and transformation, just like the Earth. The perfect, eternal heavens were an illusion. The appearance of the 1572 supernova empowered a new generation of thinkers to question the old authorities and to imagine a different kind of universe. If the celestial sphere was not real, if the stars were not fixed to a solid shell, then what were they, and where were they? One English astronomer, Thomas Digges, took a brave and imaginative leap. He suggested that the stars were not all attached to a single sphere at all. Instead, he proposed that they were scattered through space, stretching outwards from our sun, on and on, perhaps forever. This was a revolutionary idea, one that would begin to dismantle the old universe and build a new, infinitely larger one in its place. Thomas Digges's idea was mind-bending. He took the old model of the universe, with the sun now at the center, and shattered its outer wall. In his vision, the stars were not just lights on a distant ceiling. They were other suns, just like our own. They were scattered through a space that had no end. Some were closer, and they appeared brighter. Others were much farther away, appearing fainter. And beyond them there were more stars, and more, stretching out into a boundless, infinite expanse. This was the first time in modern science that someone had seriously proposed an infinite universe filled with countless stars. It was a picture of the cosmos that was both terrifying and exhilarating. This new idea of an infinite universe filled with suns raised a fascinating and deeply puzzling question. A German astronomer named Heinrich Olbers would later popularize it, and it became known as Olbers' paradox. The paradox is simple. If the universe is infinite and it is filled with an infinite number of stars, then no matter where you look in the night sky, your line of sight should eventually end on the surface of a star. Every single point in the sky should be as bright as the surface of the sun. The entire night sky should not be a dark canvas sprinkled with light, but an overwhelming, uniform blaze of glory. So, the question is, why is the night sky dark? This is not a trivial question. It is one of the most important questions in the history of cosmology. The darkness of the night sky is a clue, a profound piece of evidence about the fundamental nature of the universe. For hundreds of years, scientists and philosophers wrestled with it. Perhaps the dust between the stars blocked out the light. But that couldn't be the answer, because over an infinite amount of time, the dust itself would heat up and start to glow just as brightly as the stars it was blocking. The paradox seemed unbreakable within the framework of a static, infinite, and eternal universe. The simple fact that you can go outside at night and see darkness was a sign that one of those assumptions had to be wrong. Solving Olbers' paradox took centuries. It required us to discover things that diggers and Olbers could never have dreamed of. We had to learn that the universe is not eternal, it had a beginning. We had to learn that the speed of light is finite, so we can only see light from stars whose light has had time to reach us since the universe began. And we had to learn that the universe is not static, it is expanding, and the light from the most distant galaxies is stretched out and shifted to longer, invisible wavelengths. The darkness of the night sky is the evidence of the Big Bang. It is the shadow of creation itself, a silent testament to the fact that our universe has a history. The journey to understand this vast, dark universe continued. By the 18th century, the idea of stars as distant suns was widely accepted, but the true structure of this stellar system remained a complete mystery. How were these stars arranged? Did they form a shape? And where was our sun located within it? To answer these questions, you would need to do more than just look. You would need to map the heavens. This monumental task was taken up by one of the greatest partnerships in the history of science. The brother and sister duo, William and Caroline Herschel. They became the first true architects of the galaxy, dedicating their lives to counting the stars. William Herschel was a musician by trade, but an astronomer by passion. He was not satisfied with the telescopes available at the time, so he taught himself how to grind and polish mirrors, and began to build his own. His telescopes were masterpieces, larger and more powerful than any that had come before. With his sister Caroline working tirelessly by his side, as an observer, a meticulous record keeper, and a discoverer of comets in her own right, they embarked on an ambitious project. They would systematically scan the entire night sky, visible from England, section by section. Their goal was to count the number of stars they could see in each region, a brute force method they called stargazing. For over 20 years, the Herschels painstakingly surveyed the heavens. On clear, moonless nights, William would sit high up on his enormous telescope, calling out his observations of star clusters, nebulae, and star counts. while Caroline, sitting at a desk nearby, would record everything he said. It was cold, tedious, and exhausting work. They were essentially creating the first ever three-dimensional map of our star system. They assumed that all stars were roughly the same brightness, so any differences in how bright they appeared were due to their distance. By counting the stars in every direction, they hoped to trace the shape of the cosmos. What their map revealed was revolutionary. The stars were not scattered randomly through infinite space. Instead, they seemed to form a vast, flattened system, a disk-like structure. When we look along the plane of this disk, we see a dense band of countless stars, which we call the Milky Way. When we look up or down out of the plane, we see far fewer stars and the darkness of space beyond. The Herschel's map placed our Sun somewhere near the center of this stellar system. We now know they were wrong about our central position, but they were right about the fundamental shape. For the first time, humanity had a picture, based on evidence, of our home galaxy. Our Sun was not alone. It was a citizen of a great flattened city of stars. The work of the Herschels transformed our perspective forever. The universe was no longer just an abstract concept of infinite space. It had a structure that we could map and measure. Our Sun was just one member of a colossal system, the Milky Way. This discovery was as profound as the realization that the Earth was not the center of the solar system. It was another step away from our self-imposed cosmic importance. With each new discovery, the universe grew larger and our own position within it seemed to shrink. Yet, at the same time, our understanding grew, and with it, a sense of connection to this immense and beautiful cosmos. This legacy of discovery continued long after the Herschels. Astronomers built even bigger and better telescopes, allowing them to see fainter and farther than ever before. In the 1920s, Edwin Hubble used a giant telescope on a Californian mountaintop to study the faint, fuzzy patches of light that the Herschels had called nebulae. He proved that many of these nebulae were not clouds of gas within our own Milky Way. They were entire galaxies in their own right, vast islands of billions of stars, located millions of light years away. Suddenly, the universe became unimaginably bigger. The Herschel's galaxy was not the entire universe. It was just one among billions. And so the journey continues. Today, on this day, December 5th, 2025, we have telescopes that can see back in time, almost to the beginning of the universe itself. We have learned that the cosmos began in a hot, dense state we call the Big Bang, and it has been expanding and cooling ever since. We have discovered that the stars and galaxies we can see make up only 5% of the universe. The rest is made of mysterious dark matter and dark energy, substances we do not yet understand. The more we learn, the more we realize how much we still have to discover. The universe is not only larger than we imagined, it is stranger than we can imagine. From our ancestors staring at a fixed canopy of stars to our modern telescopes peering at the dawn of time, the story of our cosmic journey has been driven by one powerful force: human curiosity. It is the simple act of looking up and asking questions. Why is that star new? Why is the night sky dark? What is the shape of the stars? These simple questions have led us on the greatest intellectual adventure in history. They have revealed a universe of breathtaking scale and beauty, and our own small but precious place within it. And the most wonderful thing of all is that the journey is not over. There are always more questions to ask and more wonders to find.